Hi everyone. In my today's session, I'm going to explain about one of the structural pattern, which is called a flyweight design pattern, basically. So, what is a flyweight design pattern? Flyweight software design pattern refers to an object that minimizes memory usage by sharing some of its data with other similar objects. Okay. The flyweight pattern is useful when dealing with large number of objects with simple repeated elements that would use a large amount of memory if individually stored. It is common to hold shared data in external data structures and pass it to the objects temporarily when they are used. Okay. In general, a large number of objects uses a load of memory, and the pattern helps to break or isolate the object properties so that they can be shared across the objects. The breaking of object properties is achieved by dividing them into types. For example, intrinsic types and extrinsic types. Okay. So I will give you a simple example. Okay, this pattern can be applied when your program requires you to create millions or billions of objects. Okay, and the scenario will comes into picture in such a way that all these billions or millions of objects have some properties, some attributes, which are basically common across all the objects or same across all the objects. So when you know that if this object, or sorry, when these properties are same across these huge number of objects, there's no point in keeping it into each and every object. Basically you are duplicating, which will cause a very huge memory footprint, and sometimes your application may break because of memory out of range exceptions. Okay, so that's where the flyweight design pattern comes into picture. This pattern is most of the time applied in the gaming softwares, guys. Okay, the very highly used scenario is gaming softwares, but it will be applied in real world business scenarios also, like credit card details. Okay, for example, a credit card like a rewards credit card or a platinum credit card is basically a credit card only. There are some basic set or some common set of properties which are same across these various credit card registrations you people do, or basically you provide to your n number of customers or a huge customer base. Okay, so what this pattern says is identify such properties or attributes which are same across the objects, and then identify some set of properties which are going to change when used with end user or used with specific scenario. So that's what they say, intrinsic and extrinsic properties. So I'm going to explain that soon. Flyweight objects can store intrinsic state that is invariant, context independent, and shareable. For example, if you have a MS Word software or Acrobat Reader software like this over here, okay, the code of a character A in a given character set is always same. You apply a bold text to it, you change the color of that, you basically zoom in, zoom out. Okay, you increase its font weight, font size. Okay, but the meaning of the character A is always in ASCII character set. Okay, it will be a numeric code which is not going to change. Okay, that's why it's called an intrinsic state. Okay, now provide an interface for passing in extrinsic state that is variant, context dependent, and can't be shared. For example, if you see this word doc, this PDF document I have opened here, there are a n number of A's here. Okay, because we use multiple time the A, B, or whatever character. There are thousands of occurrences. Now, in those thousands of occurrences, the position of the character is always different. Okay, it won't be same. It may appear at any number of times in many places. So this is called the extrinsic state. Okay, so that's what flyweight design pattern says. Basically, separate the intrinsic state and extrinsic state. Okay, and then what you have to do is provide an interface for passing that extrinsic state. Okay, so I'm going to explain this in detail with a UML diagram. So let's move on. Clients can reuse the flyweight objects and pass in extrinsic state as necessary, reducing the number of physically created objects basically. So the client which wants to use, okay, the program, right? So what it does, okay, it simply passes for your character class, it simply passes the extrinsic state like font size, okay, font color, its boldness, okay, its location. All these things will come as extrinsic state to that particular character, but your character will be only one, that is A. Okay, thus reducing the number of physically created objects. Okay, so let's go through the UML class diagram. Very simple. you have a flyweight interface, okay, which performs an operation on extrinsic state. Okay, the parameter, look at the parameter over here, it's extrinsic state. Okay, this is the interface basically, and there will be the concrete implementation, which is flyweight 1, which will contain its own intrinsic state. On this intrinsic state, it applies some operation using the extrinsic state, the external state, which you are supplying, like font size, font color, okay, and various other kind of extrinsic properties, which are going to change for each and every object. Unshared flyweight 1, yeah, there is a possibility to create a flyweight object which is not going to share its properties basically. Okay, and then a flyweight factory which takes the responsibility of creating your flyweight objects. Okay, it maintains a cache, and if that object is already available, it will returns that object. If it is not available, it will create that flyweight object, does the initialization, adds into the cache or the pool, flyweight pool, and then returns the object. Okay, so that's what I have explained the flyweight. This is the interface that defines the behavior for the flyweight concrete classes to perform operations on the extrinsic properties. To perform operations on the extrinsic properties, we are passing to the flyweight's operation. Okay, so that's what they are saying here. An abstract can also be used. Yeah, you can use abstract class also, not an issue. But interfaces is a much flexible way. Then we will go to flyweight 1, the concrete implementation. This class inherits from the private interface and provides the functionality and the stateless information that will be shared across the object. Okay, so this class inherits from the flyweight interface and provides the functionality and stateless information. Okay, and then unshared flyweight 1, the unshared flyweight inherits from the flyweight interface and provides the possibility of creating a stateful object that is not shared. Okay, so that's the use of unshared flyweight. You can create two kinds of flyweights. Flyweight factory, this is the factory class that maintains a reference to list of all flyweight objects that have been created. And when the client demands a new object, first it is checked in the list or in the cache basically. If the required object is found, then it is returned to the client. If it is not present, then a new object is created, added to the cache or the list, and the same is returned to the client. Factory interface is commonly implemented as a singleton to provide global access for creating flyweights. Do remember this point. Your factory interface or the factory interface class should, you must register it as a singleton. Okay, there should be one person who should be giving you all these objects. Okay, so that's the crux of that particular concept over there. Client, this is the consumer of the flyweight objects and maintains a reference of all the objects it is using, as well as it also computes and maintains the extrinsic state of the object. Okay, so it's the client who supplies the extrinsic state to your flyweight objects. Okay, so if you take a flyweight here, circle, this is just a empty circle. Okay, but for this empty circle, who provides this extrinsic state of color, the thickness, okay, and then what else, the border color, okay, its size, all these things, the radius basically, okay, how big it should be, all these things will come from your client code. Okay, well, let's go to one simple example in the C sharp. Okay, so I have basically created a program, I have developed a program over here, very simple actually. So just conceptualize, we have a space, the interstellar space, and this space contains various objects like stars, planets, okay, a lot of things basically, interstellar objects. So what I have done is, in this space, which is my flyweight interface, okay, public interface I space, what I'm doing, I have providing some external operations, or the operations you can say, set brightness, passing the brightness value, and then set position x comma y. So my space, I basically, my interstellar space, I treat it as a xy graph now for the time being, and I'm going to set this object. So public class ellipse. So my both planet as well as star, both are elliptically in shape, right? So that's why I use the public class ellipse. It has a height, width, color. This is the intrinsic state. Please provide keen observation. Okay, this is your flyweight interface, okay, which will basically supply some operations which will accept the extrinsic state like brightness, coordinates, etc. Whereas this is the intrinsic state, which is basically same across all the objects, okay, which is not going to change much. Okay, so height, width, color, okay, And then the planetary type, what kind of planetary object I want to create, star or planet, that I have encapsulated into this enum. And yeah, the concrete flyweights as per my UML diagram, like this. Concrete flyweights basically over here. So first one is the planet, which basically implements the I space interface, and it contains a reference to my ellipse. Okay, so public static ellipse star shape equal to new ellipse, which is width height is 30 30, and I'm passing the color as red here. Okay, and then I'm providing the extrinsic states here, position x and position y in the space, and then the brightness also. Okay, and as I'm implementing from the I shape interface, I have to provide implementation for set brightness and set position. See the extrinsic state information coming to this particular flyweight object, planet. Okay. So whatever brightness or XY coordinates you send from your client program or main program, those will be set on to this particular flyweight object. And these are extrinsic in nature, whereas your ellipse is intrinsic state. Okay. So to string a planet at located, okay, a planet is located at position x comma y coordinate and is having a brightness of this value. Simple, trivial program. Again, I created one more flyweight concrete object, which is a star. It implements I space interface. Again, I have a elliptical shape, star shape, and it has a value of width, sorry, yeah, the width and height as 10 10. Okay, and then I've given the color as blue, and again its position x y and brightness, again implementing set brightness, set position. Okay, and then toString, and then I will create a galaxy factory or space factory, you would say. Okay, so public static dictionary. Okay, planetary type I space. Okay, planetary object equal to new dictionary planetary type of iSpace. Okay, same basically. Okay, for a planetary type key, you are saving the iSpace objects. Okay, now move on. So what this particular factory does, okay, based on the planetary type you have passed from your client program or main program, first it will check its cache. In this case, it's a simple dictionary. If it contains that planetary object, if it contains, return that object. Else, construct a iSpace new object, and if it is equal to star, create an instance of star, add it to the collection. Okay, and if it is instance of type planet, then create an object of planet and add it to the your cache or the dictionary. Okay, and in the main program you would see how it works. Okay, so from the galaxy factory I'm getting a planetary object for the supplied type, and then I'm setting the extrinsic states like set brightness of 10, set position of 10 comma 80. Okay, console.writeline star, it will print the details for the first time. When this line of code executes, right, there are no objects of type stars are available, so it will basically go inside this. Okay, for star it will create a object and adds to the collection. But the moment you call the second type over here, the star 2, okay guys, it won't create a new object for you because it will simply check the collection for the type star. If there is already an existing object, it will return you that same object. That's where I am basically saving the memory. And then what I have to do is I have to uh, set the extrinsic state for this reused object like 65 and then the coordinates. Okay, this way basically I am reusing the existing objects. Okay, because the first object's work is done here. Okay, you create it, you set the brightness, you set the position, whatever task you wanted to do, you completed it. Okay, so in the second instance, what you are going to do is you will again request for a planetary type of star. You will get an object, set the brightness, set the position, and use it for another purpose. So this way you can basically create a millions of or trillions of objects. But basically, most of the time, what you are doing, okay, your cache always contains only two objects, either of type star or either of type planet. That's it. The same objects which are having intrinsic state are being reused by your client program by applying various extrinsic states. Okay, That's the beauty of flyweight design pattern. So let's go through advantages and disadvantages now. Okay, advantages of flyweight design pattern. The flyweight pattern contributes to improving the performance of the application by reducing the number of objects. Okay, yes, that is true, which we already seen because we are maintaining a cache which contains one object, okay, or one instance of object for each type of intrinsic object, intrinsic state object. Okay, and then what it does by using the extrinsic state, it basically performs various other operations on the same object. So basically you are saving a lot of memory and you are reusing the existing objects itself. The flyweight pattern reduces the memory footprint and saving the RAM as the common properties are shared between objects using intrinsic properties. Okay, so basically if you see this program, okay, this ellipse over here, this intrinsic state is basically kept inside this concrete flyweight object. And when you see the way we resolve these objects, or whenever we request for the object, they are basically created once and maintained in your cache, and the same objects will be returned for the further reuse. Okay, this block, if it is already there, it will simply return that object itself. So you have to reinitialize and perform whatever operation you want to do by passing extrinsic states. Okay, so that are the advantages. And disadvantages of flyweight design pattern being, if there are no shareable properties in an object. See, whenever you are designing your system, okay, you have to first analyze, are there any shareable properties in an object? Okay, if there are no shareable properties, then this pattern is of no use. Don't use it. Okay, if memory is not a concern, implementing flyweight design can be overkill for the application. See, if you have a system with a powerful RAM configuration, okay, implementing flyweight design can be overkill for the application. Okay, but most of the times we have to design our system in such a way that it should consume less memory. So always consider making use of this pattern. The pattern introduces code complexity. Yes, there is a complexity associated because if the number of types keep on increasing in your system, right, like in my code, basically the planetary type over here, if they keep on adding various other type of planetary type, you have to maintain its respective concrete classes, and then you have to put the equivalent cases or if else condition in your factory. And this, okay, and also you have to update the unit tests associated with them accordingly. Okay, so these are some disadvantages, but I don't think so they cost much basically. So when you when you are pretty much sure that your system has some objects, okay, and where these objects are sharing a lot of properties which are basically common in nature, which won't change for each and every object, then please think of applying this pattern. Okay, I think this particular pattern is mostly applied with the gaming softwares most of the times. Okay, in order to minimize that memory footprint. Okay, so that's the use case mostly seen. So thank you for listening, and yeah, have a nice day, guys.